It says solve the equation. Okay. So I think I did an earlier video on some of the special cases of absolute value equations and inequality, so we're just going to move forward. You have to check out that video. So let's rewrite the original. We have 3x squared minus 2x, absolute value is equal to 21. So we've already isolated absolute value, so the way we handle this is in the following way. We just rewrite it without the absolute value. 3x squared minus 2x equals 21. And then I like to call this like an or flip. So we're going to say or. We rewrite the left, 3x squared minus 2x. Now, if this were an inequality, we would flip it here, but if you flip an equal sign, it stays the same because it's symmetric on the vertical axis. It's symmetric all over, but I would normally, but if there was an inequality, I would flip there, and then we flip the sign of this part. Okay, so this is what I mean by or flip. So then we solve these two and check in the original. So if we set the left one to 0, we're going to have 3x squared minus 2x minus 21 equals 0. So then we'll quickly see, oh, we're looking for two numbers that multiply to give us 42, 7 and 3, right? 9 times 7 is 63. Okay. So two numbers that multiply to give us a negative 63 and add to give us a negative 2. Now this is what, 9 times 7? So then this is negative 3 times 3 times 7, right? So those are the factors that we're going to play with. So we can just go down the list. Negative 1 is 63. That adds to 62, so let's keep going. We can't do 2, but we can do 3. And we have 21, and that adds up to 19, so that sounds good. 3, 4, 5, 6, 7. So next we can do 7, and we have, what is that? Negative... or that's a 9. This adds up to positive 2, so we're going to say 7 and negative 9. This is the line that we're looking for. Okay, these are two numbers that multiply to give us negative 63 and add to give us negative 2. I am purposely going to put the 9 next to the 3 and the 7 next to the 2. So I'm going to rewrite that negative 2x as negative 9x plus 7x. Okay. Then the 3x squared comes down, the negative 21 comes down. Now we have 4 more terms, so the technique here is factor by grouping. So what can we factor out of the first two? Well, the first two both have, what, a 3x? And then we're left with x minus 3, it looks like. So the hint is that we're looking for another x minus 3 over here. Okay, we can factor out a 7 from both of those. If we distribute to check, we get 7x, we get a negative 21. Okay, so then we factor out the common binomial factor. So this x minus 3 merges, and we get x minus 3. And what's left is 3x plus 7 equals 0. So then from here, we see that x equals 3. Negative 7 by 3. Okay, so those are two choices that could work there. Let's solve the other one, and then we'll go from there. So over here, we have 3x squared minus 2x plus 21 equals 0, right? So what is that, 63 again? So two numbers that multiply to give us 63 and add to give negative 2. Again, this was 3 times 3 times 7. So then let's look at the factors. So we have, and we're looking for the line that adds up to negative 2. If we look at the list that we generated on the left, it looks like there isn't anything that does that. Because those were all the factors on the left, so we did just remove the negative. Let me look at the discriminant, like if I was using the quadratic formula, right? So let's do like this for the quadratic. So if we look at the quadratic formula, we got x equals, what, negative b plus or minus the square root of b squared minus 4ac all over 2a. This is a formula you should know from math classes. Most math teachers want you to know this, so you should just commit this to memory. Let's look at the discriminant. So if we go ahead and plug in the values, negative b, so that's going to be 2 plus or minus the square root. That's going to be negative 2 squared minus minus 4, A is 3, and C is 21. Okay, let's see what kind of results we get. Over 2 times 3, right? So then that's going to be 2 plus or minus, now that's a 4. And that's going to be what? 63 times 4. 63, 126, 240. I think that's 252. That number might be a little off. I'm just doing it off the dome. But the whole point is, it's going to be a negative discriminant, which means imaginary results, because we can't take the square root of a negative. So I'm going to say no real solution. Not a real solution here. Okay, let's go back to our question. It says, use a comma to separate as needed. Oh, A plus BI. Okay, type an exact answer. Oh, so they want those solutions. Okay. Well, let me check these numbers then. Has to load again. Okay. So I'm just going to put all of that into the calculator as soon as it loads. Do I have to? Okay, that's what I said. All right, and let's do it like that and like that. Okay. I'm tempted to put the original in. I at least want to put the discriminant in to make sure I did that proper. -2 squared minus 4 times 3 times 21. Okay, that's what I got. Okay. So we know it's an I, so then we're going to say 2 plus or minus I times the square root of 248. Let's see, 248, let's see, divided by 4. Oops. 248 divided by 4, 62. Can we divide that by 4? I don't think so. 15.5. Let's see, 62 divided by 2 is 31. 2 and 31. I think that's a prime. So, 6, 2 plus or minus 2I times the square root, 248 divided by 4, 62, over, I think that's a 6. These are all divisible by 2, so then if we divide everything by 2, we get 1 over 6 plus or minus, sorry, that's a 3. We get root 62 over 3. And let's put the I, well, it's supposed to go here. Let's just put it here. Okay, so those are the results there. I am probably just going to look at the answer just for the sake of time, but what I'm getting is that x could be 3, x could be -7 by 3, and then x can be a third plus or minus root 62 over 3i. Hopefully I didn't make any mistakes here. I'm just going to look at the answer, but you want to check by plugging these into the original. If you were on an exam, you would check by plugging these into the original. Let's see, I think I have the solution here. Let's copy that. I'm going to paste it right here. And let's compare. So we got 3, -7 by 3, 1 over 3, plus I times the square root of 62 over 3, and then 1 over 3. Okay, so these are correct. Okay. So we're going to end this video here. And again, like on an exam, something like this, you would check by plugging into the original to the best of your ability. Okay. All right. And so with that,